Mandy started the recording. I think it was Mandy anyway. So that means we need to get started. Not going to wait anymore. So let's talk about TypeScript 101. Who's excited to talk about TypeScript? So I think this is actually a very apt presentation to give right now, because I sort of built this around the misunderstandings about TypeScript, or the things that people on the Swarm team were struggling with. And I assume if people on the Swarm team are struggling with it, probably the entire organization is struggling with it. So you can tell me how I actually did in that regard. So the title of this talk is a static typing saga, because that's really what it is. I think types are one of the most interesting things about programming languages in themselves. They're definitely, probably, I'm not sure if that's a thing, but they are one of the most academic concepts when it comes to programming languages. Maybe one of the reasons that I'm attracted to them so much. But let's start out by heading over to Mentimeter. And let's answer our icebreaker question. Someone's on top of it. That was Ryan, apparently. Like everyone to answer this question for no other reason than I make sure everyone's got Mentimeter pulled up and working. We got 3 for Vim. 5 for Vim. Nice. Surprised no one's going with Instagram.
I think you've said once or twice that there is only one answer to this question.
There is only one answer to this question. That's true. But one of the reasons why I did this was to prove that somebody said Snapchat, somebody said Instagram. Okay. The answer is Vim. One of the reasons why I did this question is, one, for an icebreaker, and 2, just to prove that Austin would not pick Visual Studio Code. Possibly because it wasn't a choice, but I think it goes deeper than that. I think he secretly loves Vim. All right, so without further ado, let's get right into it. Who here knows this guy? Donald Knuth, yes, he's basically almost considered a deity among programming people. He wrote the book, The Art of the Computer Programming. You know, one time Donald Knuth cross-compiled all of his algorithms from binary into quaternary and subsequently created DNA. So we owe a lot to Donald Knuth. I can't believe that no one laughed at that. That was a great joke, by the way. But I guess if I have to tell you it's a great joke, maybe it wasn't that great. Anyway, this is one of his sayings that actually, it's sort of a pithy saying, but it's almost like a platitude, but it had a lot of effect on me and the way that I approach engineering. But he said, email is a wonderful thing for people whose role in life it is to be on top of things, but not for me. My role is to be on the bottom of things. Somebody tell me what you think he meant by that. Ryan, what did he mean by that?
I think to stick with the idea of the quote is like he'd rather be the reason that email works than be a consumer of email as a service.
Exactly. Donald Knuth really believed, as I believe, that in order to understand a technology, it's best to understand it from first principles. If you go out and you just try to memorize a bunch of things or try to adhere to dogma or a bunch of steps or a bunch of rules, you always sort of will never really succeed as much as you could, right? So this type is going to be a little bit different. We're going to embrace Donald Knuth's perspective. And this workshop is going to provide a foundational understanding of TypeScript, where it comes from, and sort of how it works. We're not really going to dive into syntactic details. syntax is one of the things you kind of have to learn on your own. If I were to sit here and go through syntax and say, this is how you do this is how you do that, you don't really learn anything from that, right? You will have plenty of exercises that you will get assigned after this workshop to help you build that sort of hands-on knowledge, but this is more about core principles to help you to augment your understanding of TypeScript. After you get a good idea of its core principles and how it works, that's really going to empower you to leverage the features. I think just telling you about features isn't really going to help you a lot, right? Like, but telling you why those features exist and then letting you learn the features of your own is the approach we're going to take today. Any questions about that before I move on? All right, so first thing we're going to do is take a stroll down memory lane. We're going to talk about TypeScript, where it came from, why it's here, that sort of stuff. I think this is really important. And you notice most of my lectures will start out with some sort of history about a particular technology. And I think that's important in order to let you place a technology in a context. And there's actually some science around the fact that if you can place a technology in your context, it makes it a lot easier to learn because you can chunk it better. So let's talk about TypeScript and where it comes from. It was developed by Microsoft, specifically a guy by the name of Anders Heilberg. Has anyone ever heard me talk about Anders Heilberg before? Cody, you remember who's Anders Heilberg? You're on mute, buddy.
I told myself, hey, make sure to unmute before you talk. I don't even know how to say that name right. That just goes to show you how familiar I am with that person.
Do you know who
I
he
take
is?
it this was in response to like JavaScript, like they saw something in JavaScript that needed to be amended in that there needed to be types. I don't know. That's my guess.
Close enough. So Anders Heilberg is an absolutely legendary computer scientist. He wrote languages going all the way back to Delphi. I guess that was a language augmentation. I also say I've been berated for calling it Delphi. Some people like to call it Delphi. It doesn't really matter though, which was a version of C++. I believe he worked on Turbo C, which was one of the first languages that I ever used. I guess it's more of a language environment. But Anders Heilberg also, when he started working for Microsoft, he's largely responsible for the .NET family of languages, in particular, and C#, which I think is a beautifully engineered language. Other than some of its big downfalls, I really like C#. So he concepted this idea of TypeScript and sort of growed it up. It was a completely open source project, right? Which is very different from some of the other Microsoft offerings you may be around. You can actually go out and make a pull request in the TypeScript language, which I think is pretty cool. But it was really influenced by the strong type systems in .NET. Now, Anders always sort of regretted copying the type system of Java, because Java's type system isn't that robust, right? So this was sort of his way to make up for that. So TypeScript is actually unique among type systems because it's a the static typing feature mirrors strong type systems, but they don't have to be, right? We'll talk about that a lot as we go on, but the thing is TypeScript became popular right around the time ASP.NET was losing ground or losing in popularity. Has anyone here ever used ASP.NET? Or do you even know what it is? Austin has. Yeah, well, I won't make a ton of comparisons then, but ASP.NET was built in a time where we were really trying to move to thin clients. That was the the direction of the industry, and now we've decided to go fat client route with spas and things like that. So a lot of the tooling had to change. So TypeScript is sort of something, if you were really used to ASP.NET and that way of working, TypeScript dovetailed really nice into that. It actually, the other thing that I think is amazing about TypeScript is a lot of features that were added to TypeScript just for TypeScript actually influence the ECMAScript standard. So as you know, the ECMAScript standard, it evolves over time, right? Like it hasn't evolved quite as much, but like around 2015 to 2018, 2019, it was changing every other day, right? So TypeScript had a lot of influence on JavaScript. So when you go out and you look at just plain ES6, going even back that far, you will see a lot of TypeScript things in JavaScript. And I think the interesting thing about this is how much influence .NET languages and C# have over modern day JavaScript. I find that amazing. The key milestone for TypeScript was in 2016 when Angular 2 started using it, and it looked a lot like ASP.NET, but on the client. And it was great. But before that, it was sort of sparse. But after that, it sort of blew up. I know some people didn't think it really caught fire until 2019. I don't know. As far back as 2015, I really liked using it, but I know not everyone agrees with me on that. So just to sort of drive this point home, can everyone see this code screen here? Okay, so somebody tell me which one is TypeScript and which one is C#.
C# on the right.
There you go. C# is on the right. I think it's interesting that it took a couple seconds for you to figure that out, right? Like if you look, you can see all of the influence that one had over the other. I think I actually pulled up the wrong code. Yeah, sorry about that. You were looking at two different pieces of code. These are actually the exact same piece of code that's implemented in the two different languages. And you notice like the interface looks exactly the same. The Descartes object looks pretty close to the same, except for we have some extra keywords over here. Async await work both the same. Async await actually came completely from C#. And a matter of fact, working on async await stuff, I think I've shared this with several people, was my first sort of big moment in software engineering. I got featured in MSDN magazine for some of the work I did on async await. So cool stuff. Anyway, that's really all I wanted to say about the relationship between .NET and C and TypeScript, just because I find it interesting and it puts a nice contextual box around TypeScript. Any questions about that? All right, so one of my lectures would never be complete without some self-aggrandizing. So this is a lecture I gave in 2015 for, I don't even remember which conference it was, but this is just sort of proof that I was into TypeScript before TypeScript was cool. Been doing it for a while, so that's it. But what actually is TypeScript? If somebody come off mute, someone who hasn't talked yet, and tell me just what you think TypeScript is. If you had to define it in a couple sentences, how would you define TypeScript? We know it's a language. We know it's related to JavaScript, but what really is it? Where's Jonas at? Jonas is always good to just read the slide. Kane, what do you think? I can't hear you. You're off mute, but I don't know if your mic's not working.
Can you hear me now? What?
So what do you think
Oh.
TypeScript is?
Oh,
You
my
had-
bad. I wasn't
define
saying
it-
what to you like that, my fault.
Oh,
I would say it's probably like a superset of JavaScript that adds static typing to the language, probably.
that's really good. That's actually a great thing. TypeScript is actually very unique among languages. And it's one of the reasons why I like it so much. So TypeScript is a superset of JavaScript. And what that means is valid JavaScript is also valid TypeScript, but TypeScript adds capabilities above and beyond regular JavaScript. So I also put here that JavaScript is valid TypeScript. Seritas my Latin isn't as good as it once was, but all things being equal, JavaScript is valid TypeScript, but not all TypeScript is valid JavaScript. It's a superset, right? How it works is static types actually sit on top of JavaScript. While JavaScript is more a dynamic weakly typed language, TypeScript is a strongly typed and static language with a lot of caveats. Don't take that too literally until you'll understand more as we go on. But it provides above and beyond just that. It provides a lot of high-level programming concepts that JavaScript doesn't. Things like interfaces, classes. I put classes in here. That's not actually valid. Classes exist in the ECMAScript standard now. And due to the influence of TypeScript and C#, generics, modules, decorators, enums, access modifiers, and algebraic data types. I actually think decorators is one of those things that is still TypeScript only. I'm not sure that ECMAScript has caught up yet, but ECMAScript is always staying a little bit behind TypeScript. So we'll talk a little bit more on this later. Before we go on, is there any questions about where TypeScript came from or sort of what it is? None? Perfect. Okay, so now I want to talk about types and type theory. Did I miss a Menti question somewhere? Oh, yeah. I want you guys to go to Menti. Now we're going to talk about types. I apologize for getting sidetracked there a little bit. So how would you define types in the context of programming languages? Like, what do you think a type is? We know that TypeScript adds typing, the static typing on top of JavaScript, but what is it? Like, what is a type, period? You don't have to type a whole thing, just a couple words is fine. Type as much or as little as you want. I like these. Define the kind of data that can be assigned to a variable, type of an object, different ways to classify data, assign data to value group, an identifier of what kind of data will be stored, attributes. I like that. So go ahead and vote on these. What do you think is if you had to have one definition, what do you guys think it would be out of what's provided?
Probably the two on the left.
You should be able to vote through Menti.
Oh,
Is anyone able to vote through Menti? Okay, so it looks like different ways to classify data and an identifier of what kind of data will be stored in a variable. Those are actually very good intuitive definitions. So a type sort of, it specifies how a piece of data is stored in memory. Like if you have a and these things aren't completely obvious by using type systems, right? So when you have an integer, that means typically, depending on what system you use, you either have a 32 bits of data or 64 bits of data. It describes how that data can be stored in memory and how it can be accessed and how it can be used. Because you got to remember, if you just took two different variables, like you took a string, an integer, and a floating point number, and I handed you the piece of memory that those are stored in, there's nothing stored in that piece of memory that would tell you that it is an integer, a string, or a data. They're just all ones and zeros. Or, well, if you're looking at it modern days, you would see hexadecimal numbers, right? You just see a bunch of hexadecimal numbers. You have no way of knowing actually what's in there. The only way that you know what a variable is, or the only way that your machine knows how to act on a variable, is the context you give that piece of memory via a type. So if I know this is an integer, I know the type of data that can be stored there, and I know the type of operations I can run on it. Does that make sense? You don't do a lot of low-level programming, sometimes that's not like completely clear. So if you want to learn more about types, I'm going to go through this next part really quickly because this is sort of for people, if you're okay with the definition that I just gave you and that makes sense to you, run with it. If you're the type of person who really needs to know more, let's talk about types in general. The earliest example I could find of types, I know other people say they've been around a lot longer, but the earliest example I could find of types was Bertrand Russell, and I think I've actually even assigned content to some people. Cody will understand this, right? The Cantor's original set theory had some fatal flaws in it, and Bertrand Russell tried to use types to mitigate those flaws that were apparent in Cantor's set theory. Do you want to say a couple words about that, Cody?
I'm not really too sure why you're calling me out because I have no clue what's going on.
Did
we have a conversation about this?
I sent you some curriculum on this based on set theory and things like that. Well, I'm not going to put you
Really?
on it's okay.
I got some CSS stuff. I don't remember getting.
No, this has been quite a while ago.
Oh, okay. I'm sorry.
All right, that's all right. No worry. I didn't mean to put you on the spot. Is anyone else familiar with this? Okay, well, you don't have to be. It's not that important. But if you really want to dig down and understand types, that's where I'd start. Also, if you're into functional programming at all, types are a much bigger deal in functional programming languages, except for things like Lisp, than they are in object-oriented languages. So going all the way back to Alonzo Church's lambda calculus. So this is very much, this was the alternate Turing machine sort of thing. And he made typed lambda calculus. Early programming languages going all the way back to the 1950s actually had some primitive type systems. Algol actually had a really good type system. It's actually much better than Java or C Sharp's either one. And Pascal also had really strong type systems. But I would say the heyday of type systems was in the 1970s with the ML and Hindley-Milner type systems. Has everyone heard of Hindley-Milner type systems? So most of the languages, strongly typed languages you use today use some variant of a Hindley-Milner type system, although they are heavily used in TypeScript, or sorry, not particularly Hindley-Milner, but languages such as Haskell and TypeScript. Haskell is probably the most strongly typed language you ever use, although Ada was an object-oriented language that had a pretty robust type system, and that was actually created by the DoD. So, and as a matter of fact, a lot of weapon systems are still written in Ada, although no one else really uses it. Types sort of didn't evolve that much after that until generics came along. This was another thing that was first implemented in C# that found its way back to TypeScript, and it found its way back to Java, although a very flawed implementation in Java. So modern day, there's sort of types everywhere. So if you want to learn more about type theory, you have some background on where you can start, but there's two particular sources that I recommend more than anything. Really, it's the underlying theory is sort of a mix of mathematical logic, type theory, lambda calculus, formal language theory, algebraic data types, category theory, set theory, and a bunch of other things, right? However, if you really just want to understand this, I would recommend this book, Type Theory and Formal Proof. I apologize, it's a $90 book, but it's a really good book. I recommend getting that, but there's also this category theory, which deals specifically with how types are used in more functional languages. But if you understand category theory, you've got type systems will be a breeze for you after you get through category theory. I recommend this free book. It's available on GitHub, and I think there's actually some PDFs you can download or something, but it's just a great book. I feel like I didn't really understand a lot of things about the type systems until I really dove into category theory. So, an important point I want to make here is that types are everywhere. Virtually every modern programming language is typed. And the types provide a framework for error checking, code comprehension, and performance optimization. The only language I know in modern use that is not typed is various assembly languages. I actually don't know of any typed assembly language. There may be some out there, right? I don't know. I just don't know of them. I don't really know of any loosely typed or untyped programming languages. The problem is that not all type systems are equal. Everything uses types, right? But the type systems aren't really the same. And they differ upon two different axes. The first one is dynamic versus static typing. So when you look at dynamic typing, things of this are like JavaScript, Python, and Ruby. They're very flexible, and they're actually, you can write code super fast in a dynamic typed language. There's a ton of design patterns such as late binding and other things that just aren't available in anything but dynamic type. Although I will say some of the newer languages try to get around it in sort of a strange way, but for the most part, this is a true statement. They're really flexible. You could do prototypes really easy with them. Dynamic types, there's a lot of reason to use a dynamic type system. On the other end of the spectrum is static typing. So when you're doing static typing, you have to manually specify each type that you're going to use for the most part. And if you're going to if you're going to fornicate with that type at all, you actually have to do some sort of typecasting. So this is a big issue with like languages like C. C is sort of a static typed language that's really weakly typed. You can do things like, I want to multiply an integer by a floating point number, and all hell breaks loose because those an integer is just a straight counting up the number, counting up bit locations, and a floating point number is like an IEEE floating point number. It's completely different format, but when you try to multiply them in C, it just multiplies one set of bits by the other set of bits, and sort of all hell breaks loose. The static typing is important. It would have saved me several times had C been a little bit more static type. So it allows type safety. You actually get some performance benefits because you don't have to derive the type at runtime. And the code readability, that's questionable, right? I think it makes things a lot more readable. Some people might not think they're readable. So there's also this option besides dynamic and static typing, which is just sort of when the variables are defined, right? So dynamic typing, it figures it out at runtime. Static typing, it figures it out at compile time. There's this idea of strong versus weak typing. So when you have strong typing, what that means is you cannot do operations on objects or on variables that aren't the same. So if you have a really strongly typed language, you can't multiply an integer by a floating point, right? Without doing some sort of typecasting. Now, there is things as operator overloading and things like that that a lot of languages do. Don't confuse that with strong versus weak typing. This is a difficult lecture to give because everything I say has some sort of corner case that makes it true in context. So weak typing, you see this a lot like in languages like Python, where I can take a string and multiply it by 2. And if it can cast the string to an integer, right? Like it'll just do it. That's the difference between strong and weak typing. Now I have a question for you guys. Knowing what you know about dynamic typing and static typing, and what you know about strong typing and weak typing, we know that JavaScript is a dynamic, weakly typed language. Where does TypeScript fall? Remember I said TypeScript is a superset of JavaScript. Where do you think that falls? I'm going to call on Troy.
I'm gonna go with strong type.
Yeah, it's actually, that is an actual great guess. If you just use the default configuration, it is a strong type and it is a static type. However, what makes JavaScript beautiful is it's actually, or TypeScript beautiful, is that it is a cross between the two. We'll talk more about that later. So let's talk about what happens when we I actually wanted to use some swarm code for this, but I didn't know if it caused a problem with KR, so I didn't. So I just wrote some stuff here. But anyway, let's look at this in part wisdom. First, we're going to look at a JavaScript version of this. So this is JavaScript. And if we notice, we have this impart wisdom function that just takes an object that has a name and a wisdom on it. And I've created a philosopher down here. So if I say philosopher dot, well, this is sort of, it actually, I compiled I pre-made the type system in this, so it's actually sort of blowing my point up here. But typically, if you don't cross-compile your types, do that. The demo gods are upset at me here. Okay, so if I come up here and I look at my IntelliSense that I'm getting off of here, I have all of this stuff here. Somebody tell me, because I think everyone here is using TypeScript. What would this be if I open this file up in TypeScript and used IntelliSense right there? What would happen? I'll give you a hint. What's the difference between these two IntelliSense? As a matter of fact, we'll just open this up. Open this up over here. Well, it keeps on automatically compiling up the type system for me. So my demo is crashing really bad right now. It's actually, my editor is actually reading the TypeScript configuration when I'm doing this. So my point here is the reason this demo is crashing on me, the demo gods are not happy, is because it's grabbing the types out of TypeScript and compiling them into my editor. But generally, if we have a TypeScript, and I don't even have, oh, I'm sorry. I am so confused right now. I was typing in TypeScript, but I should have been typing in JavaScript. Somebody was supposed to say, okay, so this is JavaScript. You look at that type system. And this is TypeScript. You look at that IntelliSense. What's the difference between those two? And I really apologize for totally blowing this demo to hell. What's the difference?
I'm gonna go ahead and take a guess and say that the IntelliSense for the TypeScript is more robust in that it tells you what the type is, as opposed to the JavaScript, which just tells you like what variable you're trying to, I guess, pull from.
Yeah, that's really good. So basically, TypeScript, because it is a static type language, it knows what the type of each of these is. It can provide a very robust IntelliSense for you. But there's something even more important. I am going to console.log impart wisdom. I'm going to pass stupid in here. Okay. What would happen if I typed that over into, if I took this line right here and put it here on line 20?
I mean, it's gonna break on the left side, right?
Well, let's say at compile time.
At compile on the left side, I don't think it would
Oh.
say in.
Yeah. Yeah, sorry. Wow, today is not my day. If I put this in here, it's going to break. Why does it break on TypeScript and not break on JavaScript?
Because
Why?
it's the type, right? Because on 15, you defined what a philosopher is. Sorry, little philosopher as opposed to big philosopher,
Yeah, there you go.
right? But on the left-hand side, stupid is just an object, right? So it doesn't know at compile time that stupid doesn't have a name and it doesn't have wisdom.
Exactly. So here's the thing. If I wanted to ship this code over here, the only way I would be able to find that error is if I ran every line of code in my program. It's kind of simple when you're looking at two simple examples, but if you imagine this going across several files, an entire project, it would be really easy to change the definition of philosopher, have that blow up in 100 different places that you will never find until you execute that line of code. Does that make sense? This is the value that type systems bring. They allow you to figure things out at compile time that you normally would only be able to find out at runtime. So TypeScript is a type whisperer among a sea of shouters. One of the things that's always very fascinating, I found absolutely fascinating about TypeScript. It is a groundbreaking language in that almost every other language that I know, they are either dynamic and weak, or static and strong, right? There's a few that had crossover, but for the most part, that's what they were. So dynamic and weak typing are highly correlated. Static and strong typing are highly correlated. And you sort of get the type system and you have to use it. Now you can do something crazy in TypeScript and JavaScript where you can cast everything to an object, or you could just use void pointers, void stars everywhere in C++. I know Troy likes C++, right? We were doing some C++. So yeah, Troy can tell us all about void stars after the class. So you can do these things, right? But what TypeScript gives you is the ability with configuration to have your language be as strongly typed or as weakly typed as you want, be as static or as dynamic as you want. So it's the only language I know that will support patterns that only work with strong typing, like anything that you will get out of the Gang of Four book. I know a lot of people on Swarm, and I think a lot of people on Rapid Breath have been studying design patterns lately, right? But it will also support things like late binding and a lot of the other design patterns that only work with dynamic typing. I think that's fascinating. It took types and turned it from a binary switch into a dial that you can tune to make it sort of whatever you want. Like, does anyone else find that quite fascinating? I think it's absolutely fascinating. This is why I have so much reverence for Anders Heilberg. He really changed the game in compiler, in compiler theory and the way compilers are built. Also, he did some absolutely insane things with C#, but I need to go on, or I'll talk about Anders Heilberg forever. So there's two features in particular that I like about TypeScript that sort of espouse this virtue, although the exact strong weak typing stuff, that's sort of configuration. But there's also some things that are built in. Who here has ever heard of duck typing? Cody?
I believe it was from you at some point.
Probably, yeah. Okay, so duck typing is a type of typing that says if it's like it sits between static and weak, right? Or static. I'm getting my my axes mixed up. Static and dynamic. So the way that the type system in TypeScript works is it says if a type talks like a duck, walks like a duck, quacks like a duck, it's a duck. You don't actually have to tell it it's a duck. So let's talk about this bit of code down here. As a matter of fact, I can show this code over here, which may make it a little bit easier to see. If we look at this interface, it says I have this philosopher, and philosophers have a ponder method on them. You run the ponder method, it returns you a string. Does that make sense to everyone? Now, I have a method here that says engage in deep thoughts, and it just takes a philosopher in and it runs this ponder method on it. Makes sense? Easy enough? Everyone with me? Now, created two separate objects, a duck and a philosopher. Notice that I have not specifically said that philosopher, that either one of these are philosopher, right? This is, as far as TypeScript is concerned, up to line 17 here, it doesn't know what they are. They're just random objects. We also have an ostrich. Ostriches aren't as smart as ducks, apparently. They can't ponder anything. So why is it when I call, even though I haven't said that duck or philosopher are of comply with the philosopher interface, this is not an error? Somebody tell me why that is.
It's the same as like overriding functions where it looks for the function name.
Yeah, pretty close, right? Like, so it says, hey, this engage in deep thoughts, the compiler says, I take something that's shaped like a philosopher, right? You don't have, if this were a strongly typed, purely strongly typed static language, I would actually have to come in and specify this as a philosopher before it would work, right? Like if you were doing this in C#, you could not say, hey, just pass this duck in and it just happens to match that pattern, right? This is absolutely critical if you're going to do some design patterns like late binding. Does that make sense? So I know I work with you guys a lot, and I know a lot of times you get this strange type error that says, hey, this type, it gives you this big, long, crazy error message that says, hey, this type is not compatible with this type. That is the duck typing at work. Although it can be a massive pain in the rear sometimes. I think Matt is one of the ones. Can you share some of your experiences with this? Because I know I've helped you work through quite a few.
Oh, sorry. Yeah. Yeah, I think that's where I kind of encounter the most problems is just trying to get the typing correct. So yeah, just the interfaces thing is yeah, where I have a lot of issues with.
Yeah. So does this idea of duck typing, does it sort of elucidate that a little bit for you, or?
Yeah, it makes more sense.
Yeah. So basically that's all TypeScript is trying to do. Somebody tell me what would happen if I passed in ostrich to engage in deep thoughts. Anybody?
It would break.
There you go. It wouldn't let you compile, right?
And you'd probably anger every Australian within a square mile.
There you go. That's probably the more salient point there, rather than the compiler. Any questions about duck typing? Okay, there's also this thing, such thing as type inference, which is strongly tied to duck typing. I'm not going to talk about this as much because I think this is more interesting to old people like me than it is to people who've always had type inference. But all type inference says is that you can, TypeScript is able to figure out what type something is by context, right? So if I said this, let message equal hello world, if I then tried to set message equal to 5, which is an integer, in JavaScript, that would be totally okay. JavaScript would be like, okay, my type was string, now my type is integer, don't care. Whereas TypeScript will be like, hey, hold on a second, you're trying to cast a string to an integer. Is that really what you want to do? So that helps out a lot because you don't actually have to define your types. You don't have to say what it is. It can just infer them. Are there any questions about that? I know I went through that kind of quick, but. All right. So the last thing I want to get, this is probably what I've been working with you guys is probably the single biggest stumbling block, right? And I don't blame you. This is a concept that's difficult to understand. How many people here speak TypeScript? There you go. Dan does. How many people think your browser speaks TypeScript? Can you run TypeScript in a browser?
No.
There you
No.
go. Can you run TypeScript in Node?
No. Well, TS, I don't know, TS node.
Not
Yeah,
using TS Node. Without using TS Node, can you run TypeScript in Node?
So no.
Okay. You guys are ahead of the curve here. So most likely not. Browsers nor Node, either one, natively speak TypeScript. TypeScript transpiles into JavaScript. Somebody tell me what a transpiler is.
How is it more than translation? But that's all I want to think in my head is that it's translation.
That's all it is. Yeah.
Okay.
So a transpile, the bifurcation between compiler and transpiler is typically that a transpiler converts from one language to another language, whereas a compiler actually converts into machine code. There's a lot of nuance because by that, C# and Java are both transpiled language because they both go into their, C# goes into IL and Java goes into its Java machine code. Yeah, so, but if you're using a language like C, you can actually compile into many different targets, create many different machine codes, but that's a distinction that's not that important. So TypeScript is a transpiled language. So just to sort of make this point, right? This is valid TypeScript. Does everyone know that your Chrome DevTools has a REPL in it? Somebody tell me what a REPL is. It's a read, evaluate, print loop. That just means that I can type in any valid JavaScript here and run it, right? So what's going to happen if I try to run this TypeScript in this browser right now? What do you guys think? It's going to break. Okay. So somebody tell me how we get this into something that your browser can understand. How do I convert this TypeScript into something that the browser can speak?
Get rid of the types.
Yeah. Do you have to do that manually? How do you get rid of the types?
I mean, you could delete person.
Right, but do you want to go through all of your code and delete your types? How would you do that?
Probably not.
Yeah. I'm gonna call on Austin.
We use a transpiler.
There you go. So let's look at the TypeScript transpiler. This is the TypeScript playground. You're going to get a link to this in your exercises after this. Anything you write over here on the left is automatically converted to JavaScript on the right. So if I say console.log, sagely for the win. Notice that this is the TypeScript version. This is the JavaScript version. I actually really love this. Especially, I don't use this as much as I used to, but I used to constantly come out here and type something in TypeScript just to see what the JavaScript was going to look like. One thing I particularly want you to notice, we have a bunch of types here, and this is just example code. I didn't actually write this. This is example code that I pulled off of here. Look at the difference. We have types. We have interfaces. Notice that none of that is over here in the JavaScript, right? Makes sense? If I type in this code that I just tried to run, I copy this, and now I go back. What's going to happen if I run this? It works. Okay. So we've established the fact that if we need to transpile our TypeScript into JavaScript in order for our browser to understand it. We also saw that our types, our interfaces, all of that stuff goes away. Because remember, all of that stuff is for you at compile time while you're developing. It makes developing easier. It gives you IntelliSense, and it keeps you from inadvertently using a type in a way you shouldn't. Make sense? So let's talk about the transpilation process. How do you guys think that happens?
I mean, isn't it just a compiler at that point, like behaving like a compiler? It's lexing, parsing, semantically analyzing, and generating, just happens to be JavaScript instead of assembly.
That's exactly it. But I'm specifically referring to, like in Swarm and RapidRef and in your languages, how do you get that TypeScript that you're writing in your editor to output into JavaScript? Dan, I'm going to call on Dan.
You use the TypeScript compiler, or TSC, which is
There-
usually shortcutted on the build script in package.json.
Exactly. That's exactly what we're going to do. So there's a few things. Oops, I messed up my slides. A couple important points you should know about the way that this compiler works. You have all of these config options, right? Like you notice you can target many different versions of JavaScript. Like I can compile into ES3, which is really old, ES Next, which is whatever the next version of ECMAScript is. You have all of these settings. This is how you say, like, no implicit any. All of these things is to give you the dial on how strong or weak you want your type systems, or how dynamic or static, right? So every time you compile something with your TSC compiler, it looks at these config options, and that's how it generates your JavaScript. Makes sense? So if I'm looking over here, and just to prove my point, if I say node source, what's going to happen when I try to run this file? Bam, error, right? So what I'm going to do now, if I can find my this, so I don't have to actually type all this out. I am going to run my TypeScript compiler. And I didn't get the N. So what this says is, hey, TypeScript compiler, take this wisdom.ts file, target it to ES6, use common JS modules. That's a completely different talk we can give on modules. The out directory, I want you to put it in this dist directory, and I want you to look in the source folder, use strict any, no implicit any true. Okay, right? So I'm going to run that. Was there a question? I heard something. I didn't hear it very well though. And if you
I think
notice,
it was just joining in after my meeting. Sorry.
oh, no problem. So notice now up here in the dist directory, I have this wisdom.js. Right? So now if I say node dist wisdom.js, it actually runs. Simple enough. Now, Do I really want to add all of these command line arguments in every time that I compile? Who wants to do that? Nobody. Okay, so if we're looking in the TypeScript playground, these are all of the tsconfig compiler options that you have available to you. Quite a few. Luckily, all you have to do is create a tsconfig file. If I look in tsconfig.json, this is just a JSON file that sets up all of those configuration options for us. So when I type TSC, what TSC does is say, hey, do I have a tsconfig JSON file somewhere? I need to get that, and I need to get all of my configuration from there. So if I just type npx tsc, it finds that JSON config file. It says, hey, I want you to include everything in the source directory. I want you to use this target, all this sort of stuff, right? If I go up and I look at my dist directory now, it compiled everything in that directory. Makes sense? Okay, so if you don't
Yeah.
take, go
Sorry,
ahead.
real quick, Dale. Sorry, what's a .map file?
Oh, a .map file, these are type files so that when you are debugging, it will map lines of code to TypeScript lines of code. So your debugger actually speaks JavaScript. So like if this stops on a, you can debug TypeScript, it'll actually, behind the scenes, it'll run your JavaScript. And then if you put a line break in your TypeScript, it knows where to break it, more or less. Does that make sense? There's actually a little bit more to it than that, but hopefully that's the answer you were looking for. Is that a good enough short answer? Okay. And I honestly think those map files are absolutely fascinating, the way they did that. They stole that from GCC, which was improved upon in Clang. I'm rambling now, so I will stop. Seriously, it's fascinating technology, and I highly recommend you go through it. Okay, so at any rate, are any questions about the way that TypeScript compiler works? I know I sort of went through that pretty simply, but I think it's something people get hung up on a lot. Is there any questions about that? Do you guys feel like you understand the TypeScript compiler better now, and actually what's happening behind the scenes? When you type npm build, does it make sense what's happening?
So this might open up too much of a can of worms, but like,
Yeah.
So security wise,
Mhm.
if we're writing code in TypeScript and we're trying to do the right thing security wise to our code, but then we transpile it to JavaScript, is there like an implicit, like, is the JavaScript is the transpiler good enough to make sure that like it's not inserting any additional vulnerabilities, or is that something that we should be checking for?
It's been my experience that TypeScript writes better JavaScript than I do. But typically when you run your scanners and everything, they're running on the compiled JavaScript. They're not running on TypeScript.
Oh, okay.
Yeah, so real quick, the answer is both, Adrian. So there is security scans on the code, and there is security scans on the running JavaScript.
Okay.
And there is also like I can't think of the word right now, but there's validation that like the container built is from a true source, and the code that was packaged is from the true source. The answer is everything, all of the above.
And then just another quick question, like, so does TSC do optimizations?
Yeah, it's somewhat, but there's only so many it's not like GCC or Clang where you have optimizations that can create undefined behavior and stuff like that. It's nothing like that. Like there's just not a ton of performance optimization to be had. So I will say yes, but caveated with nothing like C# or Java or any compiled language. Well, even though C# and Java aren't necessarily completely compiled, but it's not like that sort of optimization, machine level optimization that your VM offers you, simply because that optimizer is built into the browser and to Node. That level of optimization happens after you've compiled into JavaScript. Does that make sense?
Yeah, I was just curious, like, because you were showing that tool that does the translation between the two. It's like, have you ever seen like a situation where, for example, a loop that only goes through one time, like provably one time, so then TSC on the side would just strip it out, like say that loop's not really needed.
As far as I know, it does. It's not that
Like,
smart.
it's not that smart. Okay.
Yeah, it's nothing like like a lot of the like if you compile a Java loop, like it'll on an array, like it can strip out bounds checks and stuff like that. It's not doing anything like that.
Okay.
Yeah. Or if it is, I'm not aware of it. We put it that way. Okay, so you guys are who's ready to get really excited and be really happy? Woohoo! Pop quiz. Okay, run on over to Minty. And your first question: if a type system forbids null input, there's no rational need to account for null input in the code. Is that true or false? I've also provided some code over here. Is there any, because look, the first line of this code, the input, we've specifically said it's a string, so there is no, the compiler will not allow you to pass in null input here. Is that something I need to worry about in my code? Should I have a branch here that says if input is null? What do you guys think? Who's ready to see the answer? The answer is false. What happens to my types at runtime? Sure, every swarmer is sick of hearing me say this. What happens to types at runtime?
They become any.
Yeah, they absolutely go away. There is no concept of types at runtime. So if I build this, and especially if I build a library and I hand coffee or code to Dan, he is running the JavaScript version. He's not running the TypeScript version, right? So he can pass in coffee or code and his compiler is not going to catch that. So you do specifically need to account for it. Well, if you have an externally visible method or externally visible code, you need to account for times when the type system does not, you can't rely on the type system to keep certain things from happening. Make sense? Second question: what is unique about the TypeScript type system? Nice.
Is dynamism a real word?
I think it is. If not, I made it up, and therefore it will become a meme and it will become a real word. All right. If you said it's strength and dynamism, Now I can't, you got me all messed up. I can't even say the word now. I don't think I could say it in the dry run either, so I don't know why I left it in. Anyway, yeah, those things are, its ability to be dynamic and its strength are configurable. So you can have as weak as strong or as static and dynamic as you'd like. Very good. Thought I accidentally deleted one of my questions. Awesome. Anyway, so you get out of the last quiz question. Then. So. That's it. If you want to know more about TypeScript, I highly recommend just going out to the TypeScript docs. There's a ton of TypeScript books. I've read more than I really want to admit to. And there's a ton of TypeScript tutorials and everything. And they actually all pale in comparison to the docs. Just go out to the docs. They have that great playground. They have all of the information in there is well organized. It's easy to follow. It's written very well. I would say out of every programming language I've ever used, TypeScript has the best docs. So go out and use them. You're also going to be getting some exercises assigned in the Sage layout. There's 16 separate exercises. I actually started to write my own, but I found some online that are just way better than anything I could write because they've had a lot more time to develop them. So you're going to be getting those through the Sagely app. I plan on assigning them to all of the engineers. If you do not fall into the engineer class and you want them, please let me know and I'll make sure that they are assigned to you. So with that, questions? I must have explained it exemplary because no one has any questions at all. All right. Oh, go ahead. Sorry.
This may not be on the recording, but I was just trying to think like, is TypeScript as far as like the health of the language? I know that there have been other languages like Dart comes to mind of like that transpile the JavaScript. Is TypeScript, have they won the battle basically then?
That's a matter of opinion. I would say yes, as far as sheer numbers go. However, like Elm is actually a really great language. Like I know people who are using Elm with great success. So if you talk about just plain numbers, yeah, TypeScript won. But there are pockets of many obscure languages that people are excelling in. So yeah, that's sort of a sidestep of the answer. But
I guess I'm always curious about it because like, you could do TypeScript, but then I wonder if like just the community would say, just use real JavaScript, quote unquote, real JavaScript, because that's eventually where we're headed to anyways.
Yeah, there's definitely a lot of people like that out there, right? I think also there was some before the .NET days, right? This is reaching way back. There was a lot of Microsoft hate when they had a monopoly over things. And I think there's some holdouts there, right? Like there's some people who think, real programmers don't use Microsoft or whatever. But to me, those sort of arguments are ridiculous. Well, I will say back in the day, I hated Microsoft too, right? But after the .NET family of languages, especially after they open sourced everything, honestly, .NET is the most open source ecosystem in existence right now, right? Like, so I think a lot of people who hate TypeScript are standing on their laurels or sort of anti-Microsoft stuff, which seems sort of ridiculous to me. Sorry, that's a bit of a segue anyway, but yeah, there are definitely people out there who love JavaScript. I think large portions of Airbnb, I think, ended up switching off of TypeScript for some reason. Well, as far as that goes, I mean, there's people who still love Lisp, right? Like, at some point, you could call it a matter of opinion. I don't know.
That's just insane, but that's okay.
What's that?
It can just be insanity, but that's fine.
Yeah, exactly. I mean, I think, yeah, my personal opinion is I really like TypeScript. And the obvious counter argument to that is people will say that I'm in love with the academic concepts of TypeScript. However, I would say without a doubt, like I probably this weekend I worked on a bit of code that I wrote like 8 years ago, actually 10 years ago, and I think I converted it to TypeScript. I wouldn't have been able to go in and make the changes that I did as easily as I did had I not had a type system. Right? Like if you've watched my TDD talk that I give, I talk about types in there, and the Air Raid 5 rocket that basically that blew up because it didn't have a strong type system, right? Like to say that types don't help catch errors, I think you have to be in a special state of denial to believe that. However, people do, like probably people who are smarter than me. So sorry if I sidestepped that question too.
You're fine.
So, anything else? Cody's got a question.
Do I?
Oh, you lean forward. I thought you were going to ask a question.
I guess I could ask a question. Like, do you see TypeScript having a lot of staying power? I guess it seems kind of like a
Yeah,
silly
I
question.
think it is. It's ingrained in so many projects today that it would be very difficult to get rid of it, right? However, I guess it does have the escape hatch where if you wanted, I don't do this, right? But if you wanted to, you could transpile everything to JavaScript and then just start working off the JavaScript, I guess. I don't know. Which is, I believe, what Airbnb did. So do I think it has staying power? Yeah. As much as anything, I think WebAssembly is coming. It's getting more and more popular. And I think, like, again, Microsoft is ahead of the curve there with Blazor. I could definitely see something like WebAssembly upsetting all sort of JavaScript stuff. But it's rising really slowly. So who knows? I think predicting the future in tech is a loser's game.
All right.
Did you disagree with that, Dan? You just had a look.
It's a rabbit hole I don't want to go down.
Yeah. Mhm.
You never know. I guess like 10 years from now, maybe Ruby on Rails becomes everything all over again. I don't know.
Thank God I will
Something
be
silly.
retired. If Ruby on Rails comes back,
It's coming back.
Just don't talk about it at my funeral. We'll pretend it didn't happen. Anything else? Hey, thanks a lot, guys. I really appreciate you indulging me, and look for the assignment in the Sagely app. And that's all I got. Reach out to me if you need anything.